Sara Deckers from Becco. She will talk a little bit later on about compressed air.
Stefania, you didn't want to.
It's talking start.
Okay.
It's okay?
Yeah, it's okay.
Yeah, now, sorry. Now we are on air. Okay, cool. Hi, everybody. My name is Stefania Cesarano. We are here again for a very interesting webinar with Sara Deckers talking about compressed air. But first, just want to tell you a little bit thing. If there are any questions, just put them in the chat and we will, after the presentation of Sara, we will give her the questions and I'm sure she will answer all of them right away with interesting and exciting answers. For now, I think, Sara, just I will give it to you. Just who are you and what are you doing? And then go on with the show.
Okay, well, thank you, Stefania, for inviting me to present here at the Nemes Academy. It's an honor to be here. My name is Sara Deckers. I'm responsible for focus industry management at Beaker Technologies. And Beaker Technologies is an expert in compressed air treatment, which means everything after a compressor, like filters, dryers, measuring equipment. That's our expertise. Compressed air is used in many, many industries, and one of them is the food and beverage industry, which is really very interesting because that's what I want to talk to you about any minute now. So yeah, in my 15 years of experience, I've seen a lot of different installations, I've spoken to a lot of different people, and compressed air still appears to be something that's not well known. It's certainly not sexy. So it's my intention today to give a bit of information and make you all go, never thought about that before. So I hope you enjoy the presentation. I will share my screen right now and just enjoy the next hour. And as Stefania said, any questions, please just put them in the chat and I will get to them at the end of the presentation. So here we go. Let me check there we go. So if I'm correct, everybody has a vision, everybody has a view of the first page of my presentation, which is compressed air in the food and beverage process by Beaker Technologies. I'll go slowly through the presentation for now. I understand there's a slight delay in changing pages, so if I go too fast, please somebody stop me because I will rush ahead out of enthusiasm. Just a quick information about our company. Our company was founded in Dusseldorf in 1982. Bertolt Koch, which is where we get our name from, BECO is B-E-K-O, was the first guy who developed an automatic condensate drain. So there's no loss of compressed air when you remove moisture from the air terminal. He then started to grow and grow and grow, and up till now, we have 6 production facilities all over the world. We have 3 in Germany, 1 in the USA, 1 in China, and 1 in India. We're still independently owned, so we only have a family who owns the company, so we're very independent. We're not reliant on financial investment, so we're really still a family-owned company, even though we have 650 people worldwide with a turnover of about 150 million. And as it says here, we're a manufacturer of compressed air treatment, measurement technology, service, and we also provide, just like the Nemes Academy, we also provide training and education. So that's Beaker Technologies briefly. What else we do, we're members of the IFS Pathway Partner, so we have a forum on the IFS Pathway to share information about compressed air. We're a member of the Keen Food Institute in Germany, where we also provide webinars and trainings for students who are going to be food technologists, microbiologists, and anybody who's interested in developing a career in the food industry. The NFIT is also, we're also members of the board on the NFIT, which take care of food safety over the whole supply chain, so from the source right to the consumer. They gather people together to collect the information and to share knowledge as much as possible. And the BVLK, which is a German institute for fooding. Sorry, I apologize. I'm half German, half Dutch, half English. I keep on using the Dutch words. I apologize. So it's for the food industry. Now, when I give presentations and I talk about compressed air, a lot of people kind of think compressed air, I don't know much about it. So I always like to introduce people, do the best you can until you know better. And then when you know better, do better. And it's a quote from Maya Angelou. And I like to think that every day when we learn something new, we apply that knowledge. So I'm hoping at the end of this presentation, you'll be able to apply some of the knowledge that I'm providing and look at your Compostair installation a little bit differently and start questioning things, because asking questions is the only way we know better. So what am I going to talk about in this next hour or so? About 50 minutes it'll be to give chance for some questions. The risks of Compostair. Why is Compostair a risk to the food industry? What are the regulations involved? What do they tell you about how to treat the Compostair? How do we define the definition? So how do we say what is safe and what is not safe? And the regulations, which I'll show just in a few slides from now, how do we translate that into something that you can actually use to measure? So how do you translate the guidelines into actual numbers, actual figures, so that you can actually deal with the risks involved? I've given a few installation examples. Maybe you've been in a Compostair installation before. Maybe you're completely new to this, so you don't know what it looks like inside. So I've given a few installation examples on what people think is standard, what people can take care of. So if there's something in there that you think belongs there, but it might be something you can improve on. So I've given a few installation examples there. And then how do we start looking at our Compostair with regards to monitoring and improving? Because once you start measuring it and monitoring it, then you know what you've got to start with. So it's basically like a benchmark. It's a starting from zero, as we say, and then improving from that if it's necessary. And at the end of the presentation, I have a checklist. So this might be a bit of a handy tool if you go into a Compostair installation and you think, okay, let me check this and this. It's an easy checklist. Just take a look at the things on there and see if there's anything in there that you can improve on, that you have questions about in your installation. So what is compressed air? Yeah, we hear a lot about climate changes. We hear a lot about CO2. We hear a lot about air quality. Basically, very simply, compressed air is just ambient air sucked in through a compressor, made smaller, and then sent through pipework to a product or a process. So as you can imagine, the quality of the air around you has a lot to do with the quality of the compressed air in the installation. So when you look outside, what is the intake air? That's a phrase we use a lot in compressed air industry, intake air. So where does the air come from? If you're in the middle of a field in a beautiful countryside, then maybe things like pollen or medicine or pesticides that may get into the compressed air stream. If you're in the middle of an industrial estate, as you can see from the right-hand side, what kind of smoke, what kind of fumes, CO2, what kind of metals, rust, carbon are we intaking into the compressed air? So the intake air starts the quality of the compressed air. So what is actually in the air? Again, depending on where you are, it can be dirt, it can be rust, it can be soot, it can be microorganisms, which is one of the reasons that Nemes Academy and I got in touch with each other, I think 2 or 3 years ago. We first talked to each other, interested in microorganisms, in viruses, in bacteria. Anything that is in the air gets taken in. So you have dust, you have fluids, you have moisture, and you also have gases in there. What is in the air that we breathe? Now, when we breathe the air around us, because it's diluted, it's in a large environment, we don't seem to have much problem with it. We're used to breathing the air that we have. But once it's compressed, which means you get a whole huge size of air, and then you compress it, so you make it smaller. So everything in that huge area has then been reduced to a small area. Think about it in your living room. If you take all the air from your living room and put it together into a golf ball or a tennis ball, all the pollutants, all the air, all the dust, all the skin cells, all the microorganisms, the viruses are all in that one tiny space. And if you use that air, if you use that ball and put it in contact with food, then you want to make sure that that ball is as clean as possible. So you need to make sure that whatever goes in gets taken out, so it doesn't prevent any contamination for your product or your process. So the film we have here just kind of explains a little bit better what I just mentioned. If you take the air from a large space and you compress it into a smaller space and then put it through pipework, that's basically simply shown that's what compressed air does. That's what a compressor does. It compresses, it makes smaller, it reduces the size, it reduces the volume and pushes that airflow through a small pipe. So you can imagine that all the pollutants, all the moisture, oil, carbon dioxide, any types of gases are also included in that compressed air stream. So simply said, the quality of your environment air, the quality of the air on the intake side of the compressor determines to a certain extent the quality of your compressed air. So it's a nice demonstration of what compressed air actually looks like in a simple diagram. Before I was in compressed air, I never thought about compressed air. It wasn't really interesting to me. I didn't know what a compressor looked like. And then when you see this image, you think, that's actually quite impressive. It's a great system. It's used everywhere. In most industries, there are very few industries who don't use compressed air. And in some industries, it's less important for all these contaminants to be taken out. But in the food and beverage industry, it really is essential in an awful lot of processes. So just keep this image in mind when we think about what's in your pipework, in your compressed air. Just think about that. So when we talk about the regulations and guidelines, if we're talking about dirt, moisture, filth, oil, who tells us or who informs us what type of quality of the air we're supposed to have? Who guides us, who informs us and says, you are only allowed to have a certain limit of moisture, you are only allowed to have a certain limit of microorganisms, oil, and dust particles. There are a lot of certification companies out there, and in general, there's very little said about compressed air. And this is one of the things that Beaker Technologies is working on, is bringing awareness to not only these certification authorities, but like places like Nemes Academy, where we can share our knowledge and think, hey, we need to share what we have, because the more we know, the better we can deal with things. The more we know, the more we measure, the better we can produce food products. So the three particular ones I'll be talking about today are just three examples of where compressed air is mentioned. And that will be the BRC, the Food Safety System Certification, the FSSC, and the IFS. So what does the BRC say? I was just talking to Stefania just as before this webinar started, and we were saying how little is actually mentioned about compressed air in all the certification programs. And I said, yes, it's true. I said, there's only one item in the BRCGS, which is item 4.5.3, and all it says is air and other gases used as an ingredient or that are in direct contact with products shall be monitored to ensure this does not represent a contamination risk. Compressed air that is in direct contact with a product shall be filtered at point of use. So it's kind of vague, it's kind of general. It doesn't really tell me, well, what is contamination for my product? What is too much? What is too little? What is monitoring? What kind of filter do I need to use? How do I monitor it? What is the contamination risk for my product? And in general, unfortunately, it's the responsibility of the manufacturer to know what the risks are for his system. I can't tell you as a compressed air specialist, I cannot tell you, you should not have that in your product, because moisture is not always an issue for specific products. It depends on a water value in certain products. If there's a high water value in a product, it won't take on any more moisture. So moisture is less of an issue. If oil isn't an issue for a product, then oil doesn't need to be removed as much as in other systems and processes. So the actual risks are defined by the manufacturer himself. He knows what he doesn't want to find in his product, what he has to monitor, what he has to analyze, what he has to prevent. All we can do is say, if you have direct contact with your product, the quality should be as high as possible. We advise, we don't tell. We can't tell a food manufacturer what he has to do. We can only translate the guidelines into figures using a table that I will show in a few slides from here. So yeah, the BRCS just says needs to be monitored, needs to be filtered as close as possible, and should not form any risk of contamination. And that actually comes a lot into the other certification programs that we talk about, the IFS. This is almost the exact same thing. The quality of compressed air that comes into direct contact with a food or primary packaging material shall be monitored based on hazard analysis and assessment of associated risks. Compressed air shall not pose a risk of contamination. Again, very similar to the BRC, very similar in wording. Basically, compressed air should not form any risk of contamination and needs to be monitored. Now, I don't know what monitoring means to you guys. Somebody might think, hey, I have a little person watching my compressed air installation all the time with his binoculars, with his glasses. He just sits down and watches the compressed air all day. He's monitoring the compressed air. It could be you have the high-tech measurement equipment, meaning that any type of variation or deviation in quality, you get an alarm bell on your fancy computers in your big screen. Monitoring is so broad, it's so open to interpretation. So again, what does that mean for us? What does the FSSC say about it? Pretty much the same. Any compressed air used shall be constructed to prevent contamination. Direct or indirect product, including transporting, blowing, or drying, shall be approved for food contact use, filtered to remove dust, oil, and water. So the FSSC actually uses similar words, but goes a little bit further, because the last sentence here, where oil is used for compressors, and there is a potential for the air to come into contact with the product, the oil used shall be food grade. I'm just leaving a bit of silence there, because when I spoke last time on a webinar and I said, who here has ever got a jar of food grade oil from the compressor room and said, I think I'll have a drink? Nobody. So if you food grade oil in that jar is not it's not an ideal drink for you to take on a Friday afternoon after you've had a hard day's work, why on earth would you think it's acceptable to spray, pour, or use in your food product? It's less, it has less additives than mineral oils, but it still is oil that should not be used when a product comes into direct contact. So yes, food grade oil, it can be better. It has lots of other factors as well. It doesn't clean the air as well as normal mineral oil does, because there are less additives. So oil is not only used for lubrication, but it's also used as a kind of filter. So it takes out certain contaminants, certain particles from the compressed air stream. But food grade oil has less additives, so it has less of an absorbing capability for the contamination in compressed air. So food grade oil is also, because there's less additives, it doesn't go as long, so you need to replace it more often. It can be a bit of a degradation for your compressor, because it has to be changed so long, because it's less lubricating. So it's not a 100% fail safe. You're perfectly safe if you use food grade oil. There are still limitations to its use. And if you actually look on the H1 bottle, food grade oil, it says only to be used in case of incidental contact with the product. So it's not, yes, pour it on, yes, spray it all over your product. It's only in case there may be incidental contact with the product. The food grade oil, whilst in certain terms better than normal mineral oil, there are still limits to its perfection, shall I say. The last sentence, again, Food Safety System certification says a use of an oil-free compressor is recommended. Now, an oil-free compressor doesn't use oil for lubrication. There are water lubricated compressors, and there are different types of compressors that use no lubrication at all. So they run continuously, because if they stop, then there's a backflow of air, they lose air. Oil-free compressors are very expensive to purchase. They're almost twice the amount in general. I say that's not always the case. They're twice the amount for a normal compressor. They are very expensive to run, because they're running constantly, and they're also very expensive to maintain. And as I mentioned a few slides before, where does the air come from that goes through the compressor? It comes from outside. So if you have hydrocarbons outside, that will go straight through your compressor. So whilst there's no oil added for the lubrication process, you still get hydrocarbons coming through the compressed air stream. So oil-free compressors does not mean oil-free compressed air. Just a little bit of a note there for people to kind of write down a note and think, how do we know if our oil-free compressor gives us oil-free air? Measuring, and that's something I'll talk about a little bit later. So the three certification programs I've chosen, the BRC, the IFS, and the FSC, all say pretty much the same: shall be monitored, shall be filtered as close as possible to the point of use, prevent contamination, and the FSC goes one step further and says food grade oil or an oil-free compressor. And just think about the limitations of those last two comments when you next go to the compressor room. Yeah, so just basically I'm ahead of myself, and I just basically gave a rundown of what it says. So they all say should be monitored, should be filtered, may not pose the risk of contamination. This is a nice sheet for you to just think about. Again, the more aware you are of the situation, the more you know and the more you can deal with it. If you assume that your oil-free compressor provides oil-free air, you don't know. You're looking into a glass ball, look into the future. Now, this one I had just recently. I gave a presentation to our Asian colleagues in China, and even in China, they say food safety, any substance in the preparation of food must be suitable for human consumption, no additives that are not approved. So I just added this in for our previous presentation. So it's not just here in Europe that they're very, I won't say vague about the guidelines, but it's not just here in Europe. They also have all over the world. There are different laws, different guidelines, and basically says food law guide. It says food law guide. So it's not a law, and that's unfortunately in Europe we don't have any laws on food quality with compressed air, just these guidelines that I've mentioned before. So the definitions, okay, so those vague guidelines that we have, how do we use those guidelines to define hard numbers that we can actually measure in order to classify our compressed air quality? Because if you look at your compressed air installation and says it poses no risk of contamination, it's kind of guesswork because you can't measure it or you haven't measured it. So the definitions need to be defined as what is direct contact, what is indirect contact. Direct contact, according to the VDMA, which is the German Institute of Mechanical Engineers, they say direct contact is when the compressed air comes into direct contact or through the primary packaging as blower air that is specifically aimed at the product, or which reach the airways or unprotected skin. That's direct contact. So a couple of examples of direct contact. We have one customer who has ice cream. Compressed air is blown directly into the ice cream to provide some aeration, to provide some fluffiness to the ice cream. A bakery uses compressed air often to blow open packaging. Primary packaging, compressed air is blown into the bag, and the bag then opens so that the bread or the buns or the cake or the cookies can then get efficiently put into the bag. Now, if that compressed air is contaminated, if that compressed air has any oil in it or any moisture in it, then that product will be affected by it, and maybe the shelf life will be reduced if that's the least important of the thing. But it may also be that there's a bacteria blown in there. There might be a little virus in there. There might be microorganisms in there, and you will soon get moldy bread or moldy cake sooner than you expected. And because we're using less and less additives these days, we're using less and less E-numbers, we're trying to preserve the food as much as possible, but by keeping it as natural as possible. It means that you've got to consider all the aspects within the process. So compressed air needs to be clean in order to preserve the shelf life, in order to keep the product safe for as long as possible without all the extra additives. Indirect contact is slightly different. Indirect contact is when the compressed air comes from a nozzle, for example. So when compressed air goes through a cylinder or goes through moving equipment, so like a robot, moving arms, there is a slight expansion of the compressed air, which means it's expanded into the atmosphere, which means the contamination or the pollutants are then diluted into the air. So there's less of a chance of contamination because it spreads out and over a wider surface. So we call that diluted with the ambient air. So then there's less of a risk because the dilution means that it's not as much of an impact with contact with the product. So we talk about indirect contact with the product, and usually that comes from pneumatic components such as moving parts, vessels, cylinders, and that kind of thing. So we have two definitions here: direct contact and indirect contact, and we need to determine in a particular process, where does my compressed air have direct contact with the product, and what quality does that need to be to ensure that my product is kept safe. Talking about numbers now, because I have a film just in a couple of slides. There's a film to give an example of one piece of equipment that has direct contact and indirect contact. Now, the VDMA has not only defined the direct and indirect contact, they've also defined levels of contamination that are acceptable in order to put the quality of the compressed air into a class. So we have a classification system, and this can be found in the ISO 8573.1, which is an ISO table. So when you look at these numbers here for direct contact, this is the top, I'd say 2 lines, a maximum number of particles. We're talking about dust particles or floating particles. which can also be microorganisms. It can be pollen, it can be dust, it can be soot, it can be anything that's just found floating in the environment and probably invisible to the naked eye. What is an acceptable level? Now you have different sized particles. I'll compare it with a football, a tennis ball, and a golf ball. So how many footballs, just for visualization, because obviously we don't have footballs in compressed air. You could use compressed air to blow up a football, but what I'm saying is we don't have footballs. And just for the generalization, just to make it a bit more visible, you have football-sized particles, you have tennis ball-sized particles, and you have golf ball-sized particles. So different sizes mean different levels. And when you talk about on the left-hand side, you see here class 2. If you just look at the column just next to it, it says 0.1 up to 0.5. They're the smallest particles. And for class 2, you're allowed to have no more than 400,000 tiny particles. So 400,000 tiny golf balls are permissible to put the quality into class 2. The tennis ball size is 0.5 to 1, and the micrograms, 6,000. So 6,000 tennis balls are allowed in there. And then we talk about the footballs, you're allowed to have 100. So if you want to have a quality class of class 2, then the particle size and the number of particles allowed is mentioned in these 3 columns. So the first number is class 2. The second number we see, which is pressure dew point. If dew point is familiar to you, then go for a cup of coffee right now. What a dew point is the point of which any moisture in the air condenses. So when temperature increases, you have usually a high humidity. When the temperature lowers again, the lower the temperature, the less moisture the temperature can contain. So the lower you get, the more moisture turns into condensation. You see it with a glass of beer on a summer day. The glass of beer is really cold. The air around is warm. Now all the particles, all the moisture droplets around that bottle of beer get cold and then turn into condensate. So that's why you get water droplets on the outside of your beer bottle. It's because the air around that beer bottle is cold and the air can't contain as much humidity as contained in the warm air around it. So you get droplets. So a pressure dew point is the dew point under a particular pressure. We call it pressure dew point. You can call it dew point. If you know what pressure you're working in, you can translate back to ambient conditions. So pressure dew point of minus 40 means there is 0.8835 grams of moisture per cubic meter of air, which is, it doesn't sound like a lot, and it's not. So minus 40 is pretty safe for food contact, which means that any moisture in the compressed air will only condensate if the temperature drops below minus 40. Now in Europe, we have had a few cold spots, but we've never had minus 40, but there are some parts of the world that the temperature will decrease below minus 40. If compressed air is used, you need to make sure that the moisture is removed, otherwise that may turn into droplets and will immediately freeze, causing blockages, causing damage to your pipework. So in general, a dew point of minus 40 in a working environment in a compressed air installation where the temperature is usually around 20-25 degrees around the installation, minus 40 is a pretty high class for a dew point. Concentration of the oil, so that can be liquid, aerosol, or vapor. Now, there is oil around us right now. We can't see it. Sometimes when you drive past a car, you can see like a cloud of something and it looks like vapor. And sometimes it's just oil droplets, very easy to see. And the class for oil is generally preferred for direct contact to be very, very high. So class 1 is basically the highest class you can have for oil vapor content. So that's 0.01. That for direct contact is what is advised by the VDMA. If you're going to look for direct contact with your food product, then we advise class 221. When you talk about indirect contact, then you talk about slightly different classes. So the moisture is the thing that changes and the oil content changes. So the particle sizes don't change that much. They're pretty much still in the same class. But the dew point for indirect contact, so where we mentioned just before, that was with moving parts, that's with vessels, that's with cylinders that move back and forth. The pressure dew point does not need to be as low as minus 40. A pressure dew point can be +3 because in a working environment where cylinders are moving back and forth, usually the temperature stays at about that temperature. It very rarely drops underneath 3 degrees, meaning that the moisture in the compressed air will stay moist and will not condensate until the temperature decreases. And especially for moving parts, Oil is also sometimes a little bit okay to have to provide a bit of lubrication so that the cylinder can continue moving. So direct contact and indirect contact are slightly different. Again, it depends on your specifications as a producer. It depends on what the manufacturer actually needs for his process. But this is the guideline that is now being translated. So guidelines from must be monitored, shall be filtered, and must not form any risk of contamination. We can translate them into these numbers, and that's something that is measurable. So here's an example in this film of a piece of equipment, one machine, which are making cookies, and they have different processes within one machine. Now you can see here nozzles blowing compressed air over the product, separating them, splitting them, dividing them. That's direct contact. And here you see moving parts, you see cylinders, all the blue cables, it's usually compressed air. Sometimes companies have a different color, but usually a blue cable indicates a compressed air line. When you look at the robot arms moving, that's compressed air is being used to move cylinders, to create movement. And when compressed air is inside a cylinder, it escapes, so you have indirect contact. So when we talk about, for this piece of equipment in particular, the quality that we would like to have would have to be the highest because that's where the most risk is. If we accepted a 242 class, meaning there's still moisture in there, this compressed air nozzle would be blowing moist air over these dry cookies. And these dry cookies would pretty much like to take on some moisture and we become soggy cookies. And nobody likes a soggy cookie. Unless you dunk it in your tea like I do. So just to get a bit of a close-up here, the nozzles here on the left-hand side of the screen, they are nozzles that blow compressed air directly into or onto or through a product. Sometimes compressed air nozzles are used to clean molds where you put chocolate in, melted chocolate molds. Sometimes it's used to clean a transporting rack. Sometimes compressed air is actually used to blow away products that are not according to specification. So you have 20 nuts and one of them is the wrong size, the wrong shape, the wrong color. Compressed air is usually sent through the system and it blows out that one nut or peanut that is not up to specification. So it's direct contact with the product. So it's usually where you can see this is a nozzle where it's blown directly onto the food product. So again, bringing the table back into view here, the quality class that we would like to see for this particular part of the computer, for this particular part of the process, would be quality class 221. Particles, class 2, moisture, class 2, and oil concentration, class 1. When we go to the second, the next picture is indirect contact. So it's the robot arms. You can see here the pipe work from the compressed air. And this is, indirect contact. So the compressed air will escape from the cylinders. You sometimes hear the movement, which means compressed air is escaping and being diluted into the environment. So the scheme next to it, the Excel sheet or the sheet next to it is the class 242 for indirect contact. Yeah. So when we look at it as an overview, just to give you an idea of the actual ISO 8573 class, this is what it looks like. It's something that has been developed by the British Compressed Air Society and ISO together, purely to give some definitions to direct contact and indirect contact. So when we look at this overview here, we had just now, for direct contact, we had class 221. So you can see with the green line around here, the first three columns are the particle size. So the football, the tennis ball, the golf ball, the three sizes. And when you look at this, the fourth column, the pressure dew point, that's the -40, also class 2. And then class 1 for oil vapor is class 1, 0.01. Now, there are companies out there who say we have class 0. Class 0 is a nice marketing story. It's basically when you look at this ISO table, the numbers that you see is up to and better than the number involved. So anything better than a -40 is automatically the next class higher. When you look at the class 1 definition, you will see for class 242, you will see 406,100 again, plus 3. But the signal is up to and including this. So anything better than that is going to be class 0. So it's still class 1. So class 0 sounds really fancy, it sounds really impressive, but anything better than 20,410 for particles and a minus 70 for dew point, anything better than that is still class 1. So class 0 is, it's not wrong, but it doesn't really exist unless it's an actual agreement between the manufacturer and the supplier of the compressor. Just underneath, just a bit of an indication as to the requirements in different industries. So the automotive industry for paintwork, oil and moisture is really not done for paintwork. You will get an awful effect. You get like peeling, you get bubbles in the paintwork. Costs a lot of money to redo a car spray paint. Pharmaceutical industry have to have class 111. They really are very secure in anything that uses compressed air. They monitor and measure it so much better. And the food industry, 221. Again, it will depend on the product that we were talking about. If it's a product that takes on moisture, if it's a hygroscopic product, it will absorb moisture, not a good thing. If it's a product that doesn't absorb moisture, then moisture will be less of a problem. So again, it depends on every product. But these guidelines do help just to create a bit of awareness on where we're going to go with this. So when we look at the process, it's not just the manufacture of the product. So when we look here, we're looking at the end product. So we're looking at that meat, the cheese, the bread, the ice cream, or the milk, and we're looking at the process here in the machine. So you see a CCP, you see a critical control point or a control point, depending on the process. It might not be a critical control point. What happens from the start is this is the intake air on the left-hand side. You see moisture, you see trees, you see cars, you see exhaust, you see industrial air. Anything in the air gets taken into the compressor. The compressor then makes it into a smaller bundle of mass, and then the oil, the particles, the microorganisms, moisture are all collected together. And just before it reaches the CCP, just before it reaches the manufacturing part of the product where it comes into direct contact, is something that needs to be taken into consideration. So the OPRP, the prerequisite program, it's something that needs to be mentioned when you talk. Compressed air needs to be mentioned in there because it can be a risk. So take into consideration that it might not be a huge risk, it might not be a critical risk, but it's something that is part of the production process. Now, providing the manufacture of the bakery or the breads, whatever, you have a silo truck. So you have a truck that's transporting sugar, milk, powders, whatever. What happens with the transport that he is bringing, the raw materials and the packaging? How did it all get into the truck? There's obviously a compressor there because in the silo truck, you need to have some compressed air pumped into there to get the powder out of the silo truck. So think about that in the production chain. Again, the NFIT goes through the whole supply chain just to see, is it all being taken care of? Not just in the production process, but also with the suppliers, also with the people who provide the raw materials, also with people who provide the packaging. Compressed air is used in so many areas of the entire supply chain. Does the manufacturer, as a manufacturer, does he know how his suppliers use compressed air? Do they monitor the compressed air as well? Because that can in the end still have an impact on his product, whether he has it all beautifully written into his OPRP, but maybe his supplier, maybe his transporter doesn't. So it's something that he also needs to address and say, hey, listen, I need you to look at the compressed air and provide me with proof that you are monitoring it, that you are keeping the values as low as possible, because I need to keep my product safe. Now, I'll just go through these installations briefly because we have about another 10 minutes. I don't want to go into the installations too much. A typical installation, you find a gray compressor, blue compressor, yellow compressor, it doesn't matter. It's an oil lubricated compressor. You see a vessel where the air is stored. Now, if the vessel here does not have an automatic drain under it, moisture can build up inside the vessel and end up, as a nice foundation for microorganisms for growth. A nice warm environment, a lot of moisture, and that can also be transferred through then to the filter, which is number 5, and then through to a fridge dryer. Now, the fridge dryer provides a dew point of 3 degrees, which means for indirect contact, this can be a perfectly suitable solution. The first thing we need to take into consideration is where are the drains to remove all the moisture from the compressed air. And that's something that every compressor has inside, but it's not always an automatic drain. It's not always a drain that drains when there is moisture. Sometimes it's a time valve. Sometimes it's a manual valve just to release water. So a standard installation for a class 2 for 2, possibly, potentially. What's the condensate treatment look like? Another installation similar, but slightly different in installments. So you have the compressor, the filter, the dryer, and then the vessel. And the vessel is then what we call a dry vessel. So the moisture has been removed by the fridge dryer, number 5, and then there's now dry air inside the vessel. Again, moisture can still happen if the temperature reduces underneath the temperature that the compressed air has been dried to, and that's the fridge dryer, 3 degrees. If your fridge dryer doesn't work, then you can end up with 5, 6, 7, maybe even 12 degrees. And the moisture in compressed air increases exponentially. So with 3 degrees compressed air, you have 6 grams of water per cube. When you go up to 25, 30, you have with 35 degrees, you have 39.95 grams. So it's an increase exponentially. The warmer the air, the more water it can contain. So again, moisture is always going to be the first thing you can look at. That's the first initial treatment that you can give your compressed air installation is a condensate drain that removes the condensate, so the actual fluid water from the system, but without loss of compressed air, because compressed air is an expensive medium. And if we lose compressed air, we're basically just burning our money. So the next installation is a similar one. It could be an oil-free compressor. So you have here an oil-free compressor. And as I mentioned previously, oil kind of washes the air, so it takes up certain contaminants. But you still need to have a class 1.1. You still need to have treatment because intake air can contain hydrocarbons. For the water-injected compressors that I mentioned previously, I mentioned it very briefly, the water quality also determines the quality. If that water is, for example, a stupid example, if it's sucked from the river to cool the compressor, you're going to have the river water quality. Now, that's never going to happen, but it's just to give you an example. What is the quality of the water used for cooling and used for keeping the system closed so there's no backwash of air? And you need to think about what happens to the condensate that comes from an oil-free compressor. The condensate there is generally quite aggressive and cannot be just removed by an oil-water separator. So that's something that I can always go into more detail in, but right now it's not the big issue because that's treatment after the condensate has been removed, and we're talking more about the actual compressed air and not so much the condensate from the compressed air. Another installation example, very because obviously that's what we like to do. We'll have a compressor with a water separator, and you can see the blue dotted lines. The blue dotted lines show where condensate can happen and where it's removed and then is treated by an oil water separator. So once you've removed all the moisture from the system, then you have less moisture in your compressed air. So we go from the compressor to the water separator, to the vessel, to a pre-filter, to a fridge dryer, to an after filter, and then we go to an activated carbon. Now, activated carbon is something that is used regularly to remove hydrocarbons from compressed air streams, so oil removal, and afterwards a measurement system just to prove the quality of the compressed air. Simple installation, often used with activated carbon. Now, activated carbon has also its limitations because activated carbon contains oil and oil vapor. But if there's moisture in the compressed air, it will also take in moisture, so then there'll be less capacity to take in the oil. So you'll still end up with oil after your activated carbon. Another limitation of activated carbon is temperature. If there's an increase in temperature, the captured oil can then evaporate and still travel through the stream. So activated carbon, even though it's often used to remove oil and oil vapor from a system, it has its limitations. You have to be aware that moisture and heat have an impact on how it will treat the oil capture the oil in a compressed air treatment. Ideally, if I'm right, this is the correct picture. Oil class 1, 2, 1. We have a compressor, we have a water separator, we have a fridge dryer, and then a vessel. Then we have an absorption dryer with I'm trying to think of the English word again, I apologize, with beads inside that capture water and then release again. So it's an adsorption dryer, not an absorption, it's adsorption. So it removes moisture from the compressed air in one vessel while the second vessel is then being regenerated. So it kind of switches towers, it switches columns to dry and regenerate the compressed air. So it takes in moisture and then it gives the moisture back out and removes it from the compressed air stream. Then we have a small activated carbon tower, just again to remove oil vapor, and then measurement technology afterwards. And the black lines coming down from every piece of equipment underneath the first separator, underneath the vessel, that is oil condensate, which is then treated by an oil water separator. The activated carbon is, again, I did mention it, is limited to its use. If you want to be absolutely 100% sure of oil-free and bacteria-free compressed air, the only way to go is a catalytic converter. Catalytic converter uses a catalytic material in combination with heat to break down the hydrocarbon chains into CO2 and H2O, and that's the certified method to remove oil and bacteria from a compressed air stream. So compressor, water separator, fridge dryer, storage vessel, pre-filter, catalytic converter, adsorption dryer, because as I just mentioned, the BecoCat breaks down the hydrocarbon change into water and CO2. So with a dryer afterwards, we remove the extra moisture from the compressed air stream. Then we have a dust filter and a measurement technology again. And this measurement technology is basically what we think you can use to monitor your compressed air professionally, exactly and efficiently. Because if you don't measure your quality of your compressed air and you don't know what the quality is, you're basically looking into a crystal ball. If you've never had any problems, we've always done it this way, nobody's ever complained, we've never had anybody sick. Yes, we can all say that when we don't know what we're looking at. So you have to think about measuring and monitoring to go towards the guidelines. We measure everything these days. We measure the pressure in our tires. We measure the petrol in our tank. We measure the electricity that we use. We measure the water that we use. We measure every step we take just to see if we're getting our steps in every day. But compressed air, we kind of think, hey, I have a good installation, it's fine. It's maintained every year, it's fine. But if you're not measuring it, you really don't know. Because sometimes you are quite surprised by the technical specifications can give you the quality that you need on paper. When you actually measure, then it turns into something different. So you turn into something that you're not quite expected. And the whole time you've been thinking, I have a great installation, it's well maintained, it's brand new, but I still have the wrong quality at the end of the pipe work. How did that happen? It's possible. I've seen it and it's possible. And it's surprising that it happens all the time because pipe work has a big impact on it. So the compressed air treatment that we have to take into consideration when you look at your compressed air treatment, look at the compressor room. Where is the intake air? Where is the compressor sucking air from? Is it a chemical area? Is it a rural area? Are you in the middle of the countryside? Are you in the middle of an industrial estate? What air are you taking into the compressor room? Which means what air is the compressor sucking in? What types of filters do you have? Do you have coalescing filters, which is basically one drop meets another drop, turns into a bigger drop, turns into a bigger drop? That's the coalescing filter. Do you have activated carbon filters, which is what I mentioned to remove oil vapor? Do you have sterile filters? You need to replace these elements at least once a year, and sometimes in some cases more often. Think about that. It's not just a yearly. If you have an installation, if I drive my car 1,000 kilometers every day, it's going to need more maintenance than somebody whose car's just left there for 3 weeks doing nothing. So it's use, it's the location, it's what is the intake air. What type of dryer do you have? Now, we only briefly talked about a fridge dryer and an adsorption dryer. There are different types of dryers which give different types of quality class requirements. Do you have the right type of dryer? If you do have the right type of dryer, is it functioning correctly? Does it need maintenance? Does it need regular replacement? Does it need maintenance done on it yearly, monthly, weekly? You know, it's something that people tend to think once a year is fine, but maybe twice a year might be better, just to keep the quality class in the same level as it's always been and what's required. Condensate treatment, what type of condensate drain do you have? Is it an automatic drain that is level controlled? Is it a manual drain, which is basically just a tap underneath a vessel? And if you forget to open that tap, then you will still have a vessel flooded with water instead of compressed air. You will not have enough air for your installation, and you'll just have a lot of moisture there. So you open the tap and buckets and buckets and buckets of water can flood out. I had that one time with a customer. He had a vessel. He said, I don't seem to have as much air available. I said, check your vessel. And he opened the tap underneath, and 12 buckets of water later, he said, I think it's empty now. So yeah, it's a little thing, and it was amusing. But when you think about the waste that is, if you just put a simple condensate drain that's automatic, that is level controlled, it is so much more efficient and so much more effective. What do you do with the condensate once you've removed it? Do you use an oil water separator? Do you have your own water treatment system? Or do you need something specific to make sure that it meets environmental regulations? Monitoring and measuring. Do you sit there and look at your compressed air? Do you blow it onto a white handkerchief and think, yeah, it's still okay, my white handkerchief is still white? Or do you have measurement every year. Do you use Draeger tubes, which are basically like an old-fashioned thermometer that we used to have when we were kids? Put it under your tongue, wait a bit, and then you'd kind of have to think, yeah, you look like you've got a temperature of 39 point. So, is it a visual thing or is it an actual digital registered 24/7 constant regulation, constant recording of the quality? And if you do that, then you have an alarm. You can say, hey, your dew point is increasing. There's an alarm going off. You need to check something. There's something wrong with the dryer that you have. So when you look at it as monitoring, if you want to look at it once a year with maintenance and that's what you call monitoring, that's fine. If that meets your requirements, that's fine. But if you want to have real security, you'd measure it constantly. So that's something we advise, definitely measure it constantly and be warned when something happens before it's too late. Pipe work. Oh, I have so many customers who I say, have you checked for leakages in your pipe work? Oh, good grief, don't get me started. I would not even like to think about measuring the leakages in my pipe work. Some customers actually install a second compressor just to compensate for the leakages in the pipe work. And that is such a waste of time. It's such an energy loss because energy costs money and we're trying to reduce energy. So when you have your compressor is turning extra hours to compensate for leakages, you're also creating CO2. So it's a simple thing. Yes, it's an awful thing to have to do, to check your pipeworks for leakages, to check your pipeworks for ball valves, which are oil lubricated when you're supposed to have an oil-free system. Leakages, if a connection is not connected correctly, there's so much in pipework that can improve the quality of your compressor, believe me. And what certifications that you follow. We've shown the three, the BRC, the IFS, apologies, and the FSSC. How do you prove to the auditor, who is becoming more and more aware of compressor because we're training them to look at the compressor installation? Do they accept you saying, my system was installed 5 years ago and I've had it maintained every year? Do they accept that from you? Do they accept that the technical specifications are the actual specifications? Do you have a high quality compressor class according to the requirements that you should have for your product? So starting from, where do you start from? If you look at your compressor installation, you've looked at the compressor and you've looked at the filters and the dryers, and you think, I don't know what quality I have according to the specifications that the manufacturer is telling me I have class 242. I have a good quality class that is suitable for my product. Check it. Do an air quality audit. Get some digital measurement in. Measure the moisture, the particles, and the oil, and then you have a benchmark. Then you have a starting point from where you can go to improve if necessary. So it provides insight with the risks that you may have. If you have a fridge dryer that's not working, you have a lot of moisture. Did not know that, I need to improve on it. It's basically your starting point. Where do you go from there with improving your compressor system? So this is the checklist that I was talking about, questions that you can ask yourself when you go into the compressor room. So if you have somebody walking through there and he says, let me have a look, and I'll see what we need to look at. So you'll see that he has, what's the compressor installation? What does it look like? What treatment do I have? Do I have proof of the quality of it? Do I have certification? Do I have maintenance schedules? Do I have maintenance proof? Just this checklist is something that you can take with you and think, okay, I don't know where the air intake comes from. Does it come from the left side of the building, from the north side of the building? Maybe it might be better to move the intake out to the other side of the building where the wind doesn't blow from the chemical industry, from the CO2, from the printers, from the nut factory. Anything can have an impact on your product, and it's sometimes just the simplest thing. It's the wind direction in which air intake is coming from. So rounding off this, and I think I'm still in time just a little bit, we have, thank you for that. Checklist is also on the homepage of Vico. We have an e-learning program just to get you into some familiarity with compressed air. We also have lots and lots of webinars available. We have some videos. We're also very, very happy to provide training on the job. So if you say, come and talk to us about it, we're very happy to do that. It's free of charge because we want to educate people to help. And we also have a white paper and practical guide. So any questions, any queries you may have about your compressed air, if you've watched this webinar and thought, oh my goodness, there's so much to learn, I have no idea, just give me a call and we'll arrange a visit for you and we'll just help you a little bit further. So that being said, I have another 6 minutes left. I would just like to say thank you for your time. And I see that there are some chats in the group. So Stefanie, would you like to guide me through?
Oh, hey, Sarah, so amazing. Yes, you got through
I
a
got
lot of,
got through it on time. Yeah.
no, great, amazing, interesting. I know it from my experience over 30 years in food processor companies, the air, the compressed air somehow, oh yes, we have something over there,
Yeah.
controlling. No.
Yeah.
Okay.
Yeah. Yeah.
Um,
True.
I have a question actually. No, first, you reminded me of a professor of mine at the university. She always told me, Stefania, nothing goes over data, data, data. You have to
True.
measure if you want to know.
True. It's
Tell
true.
me.
Thank you. It's true. It's something that people forget. They assume I have a good
Yeah.
installation. It could be 4 or 5 years old. It's been maintained. My car is 5 years old. I assume I won't get a puncture tomorrow. I still could,
But
but my
now
car will tell
one,
me. Yeah, carry on. Yeah.
yeah, I one question, Sarah. Are you aware of a food recall due to contaminated compressed air?
Yes and no. There was a case in Germany a few years ago that Aldi discovered oil or oil vapor in one of their products, and they went to the manufacturer of that product and said, how do you monitor the oil vapor content that you're using to provide this food product? And that company, I don't know who it was, but that company couldn't provide proof of it. So Aldi said, until you have some proof of how you control your compressed air, you are no longer a supplier of Aldi. It's about 4 or 5 years ago, and it happened in Germany. But Aldi said, if you don't prove the quality of your compressed air, you don't supply us.
Okay.
Simple.
So
Yeah.
there's also a lot of root cause analyzing. If they're happening something, don't forget there's
Yeah.
also air pistols, for example, for
Yeah.
direct or indirect control.
Correct.
Wow. Um,
Yeah.
I mean, I'm coming from the microbiologist side. You know me a little bit. I'm
Yeah.
keen on bacteria very much. And I mean, also, sorry, we do have here also rapid tests for pathogens and controlled and contaminated compressed air. Is there possibility that there could be something? Uh,
Yes, there is possibility. It's difficult. It's not something that you can measure immediately. You know that I mean, obviously, with your new pathogen test, you can measure quicker. I know this. It's something that's very interesting to us. But what you have to do is there's a test system with a petri dish. You blow 100 liters of compressed air during 1 minute over a petri dish. Then you put that petri dish. You obviously leave it for a couple of days in the right environment, and then you come up with a platelet with a platelet count, so CFUs, colony forming units. And you do see molds and spores, bacteria to a lesser extent. I'm not the bacterial expert. I know you are. But it is possible because moisture and oil are carriers of microorganisms. They like to travel on the back of moisture. Some of them are travel on the back of dust and particles as well. I used an example a few years ago when it was COVID and everybody had a mask on, and that mask was a filter, and that was to prevent the contamination, prevent flow of microorganisms from one person to another. It wasn't sufficient to prevent contamination entirely. So that one filter, that one barrier in a compressed air installation is not enough. You need to remove the moisture as much as possible. Removing moisture is basically the biggest and the best solution you can do to remove possibility of microorganism growth, because moisture and warmth is just uh, an ideal situation for microorganisms, and you'll know exactly which type of microorganisms you can find. But in general, a nice warm moist environment, you're going to get some molds in there. That's not going to be pretty. Yeah. So the best thing you can do is dry the compressed air as much as possible and remove the ideal environment for the microorganisms to grow. To remove the environment, just remove the interesting factors. So yeah, drying is the biggest, probably the easiest thing you can do, really.
yeah, that's right. Wow, you know something? We are really at the end of our time right now.
Yeah.
I I have some more questions, but I
Wow.
think privately we'll look at it, Sarah. That's for sure. I want to thank you once more. It was really very interesting. And I mean, the webinar is on our Names Academy homepage. Everybody can look at it. And well, I just want to say thanks again, Sarah.
You're very,
And
very
for the
welcome.
audience, yes, for the audience, see you on the 13th Friday. Peter Littleton from Chris Lanes will talk about hygiene and cleaning. And Sarah, thanks again.
You're very welcome. Thank you for the invitation. And if there's any questions, just let us all know.
We will. Thanks.
Thank you so much, Stefania. See you next time. Bye-bye.